Hello and welcome everyone. So today we will solve Leetcode problem 198 house robber. So this is a classical DP problem wherein you are given an array 1 2 3 1, and then you are stated that you can steal the money. So like the elements here represent the money in the houses. So you can steal the money only on the non-adjacent houses. Like so suppose you steal one, then you can't steal two here. You can only steal the values three or one. So you can't steal the adjacent houses money. Also like if you steal two, then that means you can't steal one and three. You can steal one here, right? So what we have to do here is we need to find the maximum profit the robber can steal the money from. Maximum money the robber can steal from the houses. So if we take this example, we can see that the output is 4. How the output is 4? If the robber can steal money from here and then from here, right? These are not adjacent houses, right? So the robber can steal money from here and get the amount 4. There is no other way the robber can steal money and get more output, get more money. If we take this example, then it says that it can steal money from 2 and then from 9 and then from 1. So this is the highest money that robber can steal without stealing from adjacent houses here. So what we will do is we will create a classical, since it's a DP problem, we will create a DP array. We will create a DP array and divide the problem into subproblems. So we will say that first our problem will is not limited to this whole array. We will first limit our problem. We will first break our problem into sub arrays like first this array. So till this array, if the array is only till this much, then the maximum amount the robber can steal is one, because there is just one house available. Now let's say that our problem expands to this much amount of array, then that means here the robber can steal the maximum amount of the maximum of this or this, because like since these are adjacent, the robber can only steal money from this or this. So we know that 2 is greater than 1, so robber can steal money 2, and the answer for this array is 2. Now we'll expand our array to this, right? So we know the answer to our this subarray, and we want to find the answer for this subarray. So for this subarray, the robber can steal money from this or this plus this, that is 4, or just 2. So we know that the answer is 3 plus 1 4, because like it's the greater amount than 2. So the answer to this subarray is 4. So how did we find out that answer for this subarray is 4? We found out by taking the value of this element plus the answer to the subarray of this, or the maximum of this element plus the answer of the subarray to this, and the maximum of this, that is the maximum of the answer of subarray of this. So that means like if our dp0 indicates the answers to subarray this, dp1 indicates answer to subarray this, dp2 indicates answer to subarray this, then that means our dp2 will be equal to nums2 plus dp0 maximum of dp2, no, dp1. So the maximum of nums2 plus dp0 or dp1. So this is our answer. So in the same fashion, we will expand to our last element of the array, and we will return dp of length of array minus 1 to return our answer. So let's code this up now. So first we will see that if our length of array is equal to 1, then we will just simply return nums 0. Else we will create a dp array make int, and it will be of length nums, and our dp0 will be equal to num0 because there is just one house. Our dp1 will be equal to first I'll initialize it to 0, and then I'll check if my nums1 is greater than nums0, then that means my dp1 will be equal to nums1, else it will be equal to dp equal to num0. Now we will traverse through the array I uh, from 2 because we have already calculated answer for 0 and 1. Length nums I plus plus. Now we will check if our dp I minus 2 plus nums I is greater than dp I minus 1. If it is, then our dp I will be equal to dp I minus 2 plus nums I. Else it will be equal to dpi will be equal to dpi minus 1. Then we will return the last value of dp, length nums minus 1. Now let's run this up and see if it works. And it does. We'll submit it now. And we can see it's very efficient. So this was all for today. I'll see you in next one.